All right, we've looked at addition, we've looked at subtraction. We're now going to look at multiplication. And the point here is fluency. Now, in a later video, I'm going to get more into depth of what I mean by fluency, but fluency does not mean that a student can enact what we call the standard algorithm with some kind of quick, efficient, fast, accurate way. Fluency is much more than that. I want you to think back to when we were talking about subtraction. And in the case where we were buying furniture, and if you don't know what I'm talking about, go back to the video on subtraction where I had a problem about saving money for furniture and buying some furniture. And I think I make the case pretty clearly that the standard algorithm of borrowing with subtraction was certainly not the most efficient way. Furthermore, even if it was, the point is, how do we go from a young learner who doesn't know anything about these algorithms to one who does? And also, now I'm going to add to it, one who can choose the most appropriate algorithm at the most appropriate time in the appropriate context. So that's the big message, is about developing fluency and having mathematics be more than just mimicking procedures, but it should be an opportunity for students to engage in thinking and learning. So with that in mind, let's look at 42 times 27. There's lots of ways you can multiply 42 times 27. I know you probably know the standard algorithm. And in fact, I challenge you right now to push pause on this video, get a piece of paper and a pencil out, and do 42 times 27 like you were in 5th grade. See if you can remember the thinking that went into the reasons why you do the things you do, and pay attention to your thinking, and I wonder if you will remember all the pieces. All right, pause the video, go try it how you would have done it in 5th grade, come back. All right, if you did this the standard algorithm way, at least the way I learned it when I was in 5th grade, or whatever grade it was, I can't remember, it would have looked like this. All right, first of all, you always had to start over here on the ones, didn't you? You always had to. Why? If you asked why, the teacher just said, because that's how you do it. All right, so you'd say 7 times 2 is 14, but you wouldn't write 14. You would just put a 4 and you would carry the 1. Now, it's really not a 1. It even bothers me now to say carry the 1 because it's not a 1. It's 14. It's actually 4 ones and a 10. I carried the 10. So we put a 1 over there. All right, now 7 times 4. Ooh, it's not 7 times 4. It's actually 7 times 40. Remember, place and value matters. But anyway, 7 times 4 is 28 plus 1 is 29. You would say 29 and you would write 29. Now, back when I was in 5th grade, I just put a 29 there. Now I look at it and go, that's really a 290, isn't it? But nonetheless, that's what we did. Then, watch this. This is the way I learned it. You put down a 0. Why do you put down a 0? I don't know. They told me to put down a 0. Now, in my professional life, I've seen teachers do things like put an X there. Or I've seen teachers say, all right, put a bomb there. Because, we just are trying to find fun ways for students to not put something in that spot. And, it's just mathematically so bad to say or do any of those things. But the way I learned it was you put down the 0. All right, then you'd say 2 times 2. And I know it's not 2 times 2. It's actually 20 times 2, which is 40, which is really why I had to put down the 0, is because I was doing 20 times 2, which is 40. But back then I didn't know that. I just put down the 0 and then I said 2 times 2 and I put 4. And in my head, that was just as much a 4 as it was anything else. Now I know it's a 40. And then I would say 2 times 4, and I know that's not 2 times 4. It's actually 20 times 40, which is 800. That's all I would do. And then I would add those things together and get 4, and then 13, and then carry the 1. And then, what is that? 8, 9, 10, 11. So I would get 1134. That's how it looked for me in 5th grade. Now, how do we make sense of all of this stuff? How do we develop the fluency with 2-digit multiplication? Well, here's a way. It's called the area model. This is where we get to combine some geometry along with the arithmetic procedure. You make a rectangle. You break up the rectangle into parts. Now, 42 is really 40 plus 2, isn't it? So I'm going to make this left to right length of my rectangle. I'm going to make it 40 units long plus 2 units long. Now, I don't mean literally 40 anything. It's just long 40 and a short 2, just because it's visual to make the 40 longer than the 2. And then I'm going to multiply that by 27. And 27 is really 20 plus 7. So down here, I'm going to make a 20 plus 7. And I like to be visual on this somewhat. Let me make that 20 just a little bit longer than the 7. 20 times 7. All right, now what I've done is I've broken up my rectangle into 4 smaller rectangles. Let's think about the areas of each of those rectangles, okay? So this rectangle here is 20 by 40. Can you imagine 20 rows, 40 columns? There would be 20 groups, 20 rows of 40. There would be 20 times 40. There would be 800 of those things. 800. Do you remember that 800 we have over here? 20 times 40 is 800. And then this rectangle, this one here, is 20 by 2. Can you imagine 20 rows and 2 columns? If you had 20 rows and 2 columns, that would be 2 groups of 20. That would be 2 times 20, which is 40. Do you remember the 840 that I had over there? All right, now down in this one, I have a 7 times 40. Now, can you imagine 7 rows, 40 columns? I would have 7 rows of 40. That would be 280. And then this last one over here is a 7 by 2. 7 by 2 would be a 14. 280 and 14 is 294. Furthermore, do you see built into this very efficient, remember the history of this I shared with you in our previous video. The history of this was because of ink and paper was at a premium, we had to do our arithmetic in very short space with very little ink. And so carrying a 1, for example, which is not really carrying a 1, it's a 10. But nonetheless, carrying the 1 was just a way to preserve ink and paper. But do you see it now? The 14, the 7 times 2 was 14. It's right there. Let's see, what was the next one? 4 times 7. I said 4 times 7 in 5th grade, but it's really 40 times 7 is 280. And then 20 times 2 is 40, and 20 times 40 is 800. All the pieces are right there. And so the total is just summing all those up. We've got 800, we've got 280, we've got 40, and we've got 14. 800 plus 200 is 1,000, 1,080, 1,080, 1,120, 1,134. Look at that, the area model. Now, as kids work on this, they might start to become efficient at this as well. And what I had already, 42 times 27. And they might actually, 42 times 27, with place value being the premium here, place value being the main foundation of the thinking, we might actually have students do this now more at a traditional algorithm without the box. They might even start on the left side. They might even start with the big blocks and say, I've got 40 and 20. And if you multiply 40 times 20, you get 800. And then I've got 20 times 2. 20 times 2 is 40. I've got 40 times 7, which is 280, and I've got 7 times 2. In other words, I'm multiplying 40 times 20, 40 times 7, 2 times 20, 2 times 7. I'm just multiplying all 4 of the place value representations here. Remember, this is 40 and 2. This is 20 and 7. I'm multiplying it all together. And it doesn't matter what order you multiply it in. We just now add it all together. And you might even add it this way. Do you see the 1,000 right there? Do you see the 1,000? Do you see the 1,080? Do you see the 1,120? Do you see the 1,134? Yeah, so there's how multiplication works in developing ideas. Now, just to make a connection, because I teach algebra as well, and I just want to make a point here. If we're doing this in 5th grade to develop fluency, then look at what's happening right here. 40 plus 2 multiplied by 20 plus 7 is something like, if x is 20, yeah, I'm taking you to some algebra. If x is 20, 40 is 2x, because 2 times 20 is 40. This is like a 2x plus 2 times an x plus 7. Yeah, and I don't know if you remember your algebra, you probably learned it. I would never say this in my class, but students might learn this as FOIL. First, outside, inside, last. You FOIL this and you get 2x squared plus 2x plus 14x plus 14. It's a whole thing in algebra. But look, if we start fifth graders thinking about multiplication in this way, all we're doing is setting them up in that learning trajectory for a future of algebra. In my algebra class, we're going to do this. These are called binomials because there's two terms. So the product of two binomials, we're going to do with the area model. And I hope that connects back to a student's fifth grade experience. All right, now there's lots of ways to multiply. I'm going to share some with you in this module, but I just wanted you to think about that, multiplication. All right,